Maximum power transfer. And let's say I Thevenize my circuit and I have V Thevenin here. And I have Z Thevenin here. And the question, what value for ZL should I use here to give me a maximum power transfer? What value I should use for ZL that will give me maximum power transfer? Well, let's look at the current going through the circuit. What is that current equal to? Isn't that V Thevenin divided by what? Z Thevenin plus ZL. Now, normally, you know what V Thevenin, you know what Z Thevenin. So the one you're trying to adjust is this one. I'll put a line going through it. That means adjustable. This is the only one that's changing. This is just a constant. You already calculate them. This one, you're trying to figure out what value should I use here. I can't change these, but what should I put for a number or a value such that the power delivered to this is a maximum power? What's the voltage right here across that ZL? What's the voltage across the load? We'll call it VL here. Isn't that voltage division? That's voltage division. Now I can write this in phasor. Boy, I'm looking for a nightmare here. Because to write this in phasor, let's assume V Thevenin has no voltage. Well, how can I make it pretty? Let me think, how can I make it pretty? Let's assume V Thevenin actually has no phase. So that's V Thevenin. We know Z Thevenin is going to have a real and imaginary, so is this. So this is R Thevenin, the real portion, plus RL, and has imaginary value of J. Let's use what? X Thevenin, that's the imaginary part, minus X or plus XL, not minus it, plus XL. And this one, I'm assuming V Thevenin doesn't have anything, no angle. V Thevenin times ZL, which is R Thevenin, RL plus JXL over the sum of them, R Thevenin plus R sub L plus JX Thevenin plus X sub L. The magnitude normally is what? What is the magnitude of I? Magnitude. The top is just the real value, is V Thevenin. The bottom is the square root of the real portion square and the imaginary portion square. That's the magnitude. And the angle, the phase angle for I will be the angle on the top, which is 0, minus the angle on the bottom, which is the inverse tangent of the imaginary over the real, x Thevenin plus xl over r Thevenin plus r sub l. That's the magnitude and the angle for I. I can do the same thing for VL, the magnitude of it and the angle.
J squared would be -1, wouldn't it?
Which one?
J squared.
J squared is -1, correct. You don't square the j.
Oh,
For, you're talking about here?
yeah.
No, it's the real portion square plus without the j.
Okay.
The imaginary portion square.
Okay. Can you bring it up a little bit?
Trying to come up with like a nice way, but I don't think I can come up with any nice way to write that.
That's phase angle.
That's the phase angle, the angle for this current, for I. We're going to do the same thing for V.
It says 0 minus.
0, because the top has no angle.
Minus.
Yep. It's the angle of the top minus the angle on the bottom. The top has nothing. The bottom has the inverse tangent of this over that. This one's a different story. VL is a little bit uglier. The magnitude of VL, here's VL. V Thevenin is just a pure number, so it's V Thevenin times the value of this. Well, what's the value of this, the top, the magnitude? It's the square root of the real portion square plus the imaginary portion squared. It's always the real square, the imaginary square. This one, the real square, the imaginary square. The square root of the real squared plus the imaginary squared. That's the magnitude of that. So now I'm working on V here. The phase angle is going to be the inverse tangent. The top has an angle, which is the inverse tangent of the imaginary. The imaginary is XL over the real, which is R sub L, minus the inverse tangent of X Thevenin plus XL over R Thevenin plus R sub L is always the inverse tangent of the imaginary minus the real. Imaginary minus the real. And now, what was the average power? Let's see, what was the average power? P average, if you remember, it's 1/2 V max, I sub max, cosine, theta V minus theta I. Plug them in. 1/2. What's the amplitude of the voltage? That's this number. That's what V max is, the amplitude. That's this one. All of this. Told you I should have just wrote the equation. Times. This is V max. What's I sub max? Can you still see I sub max? It's right here. That's the magnitude of it, which is V Thevenin R Thevenin plus R sub L squared plus X Thevenin plus X sub L squared times cosine theta V. Where's theta V? The phase angle. That's this one. Minus theta I, which is that one. Guess what's going to happen? When you take this angle minus that angle, what's the result? XL over R sub L. This piece will cancel that piece. It's the same thing. See him? So this angle, this is theta V. This is theta V. And this is theta I. When you subtract them, this one minus a minus, going to make that a plus. This one plus that, these two pieces will cancel, you end up with that piece alone. If you clean this just a little bit here, P average is going to be 1/2 V Thevenin times V Thevenin is V Thevenin squared R sub L squared plus X sub L squared over, the bottom is the same, that means the square root will disappear, and it's cosine XL over R sub L. Not X times L, X of L over R sub L. If you want that expression to be big, because that's what we're looking for, maximum value. If you want it to be big, when you have a fraction, what do you want to happen?
Very small.
On the bottom. And the only thing you can do on the bottom to make it small is to cancel these two. Because you square it. When you have a number, when you square it, it's going to be 0 or positive. So this will never be negative. So the only thing I can do, you say, well, maybe if they cancel each other. This is going to be positive, that's going to be positive. So for the bottom to be small, that means I need this guy to be 0 or this one to be 0. Well, if you make that one 0, if you make this one 0, that means what? XL has to equal what? Negative X Thevenin. If you do that, this becomes 0. It's gone. And if you let R sub L equals R Thevenin, this turned out to be actually what we're looking for. So for maximum power transfer, you want, here's the equation I'm trying to derive, all this math to derive it. For maximum power transfer, average power, I'm going to say power, average power. I'll put average here. You want Z Thevenin or Z load equals Z Thevenin conjugate. That asterisk means conjugate. So if Z Thevenin is equal to 2 plus 4j, you want ZL to be what? 2 minus 4j. If Z Thevenin equals 5 plus minus 3j, then you want ZL to be what? 5 plus 3j. if Z Thevenin is equal 5 angle 30, you want ZL to be what? 5 angle negative 30. That's what a conjugate means. You do that, things will work out. I got your email. I didn't get a chance to look at it.